promised to also do a graph of a cosine function with the phase shift. So here is an example of, here, let's get white, a cosine function including a phase shift. So let's do y is equal to, let's do a cosine function with every single, transformation that you guys might see. So let's do y is equal to, let's do a -4 times cosine of, I'll make it ugly numbers, 3x minus 2 pi plus 3. All right. Again, you're going to be asked for amplitude, find the period, find the distance between the key points, especially for my students, to help you with those x coordinates, right, of those key points. Find the phase shift if there is one. Find the vertical shift, VS is vertical shift, and tell me if there is a reflection. Again, amplitude. Coefficient of the cosine, always take the positive version of it. Amplitude in this case is 4. Period is always 2 pi divided by the coefficient of x, in this case 3. 2 pi divided by 3. Always 2 pi divided by the coefficient of x. Distance between key points, I tell my students take the period and divide by 4. So if my period is a fraction, then I'm going to show it and represent the division of the period and 4 by the division of two fractions, 2 pi over 3 times 1/4. So it's a little bit easier. 2 goes into 2 once, 2 goes into 4 twice. I get a pi over 6. Right? Multiplying fractions. 2 and 4 have something in common. 2 goes into 2 once, 2 goes into 4 twice. Multiply across the top, multiply across the bottom. My distance between key points is pi over 6. My phase shift. What do I do with my phase shift? I'm going to take the opposite of this. The opposite of this. So if it's minus, I'm going to take a plus. Plus 2 pi divided by the coefficient here, 3. Okay, so this is a coincidence that the phase shift matches the period. This does not always happen. The period is found by taking 2 pi divided by this coefficient. The phase shift is taken by, or is found by taking the opposite of this divided by the coefficient of this. Okay, vertical shift is up 3 units. Right? Up 3 units. And do I have a reflection? Yes, a reflection over the x-axis because of the negative in front of the coefficient of cosine. Now again, I'm going to show you guys all my stuff. I'm going to go ahead and do it with a table, key points. Hopefully you're practicing enough where you can kind of skip this step, up to you, without vertical shift and with vertical shift. Same thing as before. We're going to do ordered pairs, so I'll just set that up now. You know that it's more likely 5 key points with the vertical shift. Let's set it all up. This stuff does not change. Now, key points for cosine. Cosine makes that U shape, right? So it goes from a max to an intercept to a min to an intercept back to a max. So my key points on this table, I'm going to go from a max to a intercept to a min intercept back to a max. Now, remember that, again, cosine has that U shape. Remember that if I'm going to go ahead and reflect across this middle line, then the maxes go down here and become mins, and the mins go up here and become maxes, right? If I reflect this type of little curve, then it does this, doesn't it? With a reflection. So the maxes become mins and the mins become maxes. So the way that I'm going to take care of my reflection is convert the maxes to mins here and the mins to maxes. Very simple. I don't have to think about it anymore. Once I do this, the reflection is taken care of. Right? Remember that we had a reflection because the coefficient was negative, right, over the x-axis. So the way that we take care of that is here. After we write our key points, change all your maxes to mins and all your mins to maxes, and you don't have to think about it anymore after that. X coordinates of our key points. We're going to start with the phase shift if there is one. And the phase shift is 2 pi over 3. So my first x coordinate is 2 pi over 3. 2 pi over 3. I should have made more space. How do I get to the next x-coordinate? That's what I tell you guys to do this distance between key points for. We're going to add pi over 6 to every x-coordinate to get to the next one. So I'm taking this 2 pi over 3, and I'm adding to that pi over 6, right? I'm taking, again, all these x-coordinates and adding to it pi over 6 because our distance between key points is pi over 6. We're adding this to every x-coordinate to get to the next one. So this is a 6 pi over 6 plus a pi over 6, right? Sorry. Oops. Why did I do that? This is a 4 pi over 6. Common denominator, right? I need to multiply by 2 by 2. So 4 pi over 6 plus pi over 6. So 4 6 plus 1 6 is 5 6. Can't be simplified. Put a pi next to it. 5 pi over 6. 5 6 plus 1 6 is 6 6 pi. 6 over 6 plus 1 over 6 is 7 over 6 pi. 7 over 6 plus 1 over 6 is 8 over 6, which you must simplify. 4 over 3 pi. Right? I'm adding each of these, adding pi over 6 to get to the next one. Now, I always tell my students to verify that they did this correctly. Take the last x-coordinate, 4 pi over 3, and subtract the first x-coordinate, 2 pi over 3. What happens when I subtract the 2? I get 2 pi over 3. What is this supposed to match? It's supposed to match my period. Right? Take the last x-coordinate, subtract the first, and that difference should match the period, which it does because one full cycle occurs in that period, 2 pi over 3. Without the vertical shift, all my intercepts occur when y is 0, right? To get min and maxes, we look at the amplitude. The amplitude is 4. The min now will go down to a -4 without vertical shift. The max will go up to a 4, min -4. Very repetitive. Now again, this is without the vertical shift. Easy. With the vertical shift, all the x-coordinates stayed the same. The y will change. The vertical shift was up 3 units, up 3 units. So I'm going to add 3 to all of my y-coordinates, right? The vertical shift was up 3 units. So add 3. So -4 plus 3 is -1. 0 plus 3 is 3. 4 plus 3 is 7. 0 plus 3 is 3. -4 plus 3 is -1. And now I have all my points for what we call the key points. Again, like I said, you do this enough, it should be very, very easy to go straight to the graph. So let's assume that I didn't do this. Let's go to the graph and see what I mean. Let's set up the graph. Okay, let's make it nice and big. X, maybe go up a little more. Y. Okay, we'll count on the y-axis by 1. Again. And down. Label everything for your instructors. They're going to want to know what they are. Now, again, how do I determine the way to count on the x-axis? How do I know how to count? This is why I tell my students, find the distance between key points. This is how we're counting along the x-axis. So, I'm starting with pi over 6, or 1/6, right? Pi over 6. 2 pi over 6, or pi over 3. 3 pi over 6, or pi over 2. 4 pi over 6, or 2 pi over 3. 5 pi over 6 does not simplify. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6 is 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. And then, of course, in the negative direction, -pi over 6, blah, blah, blah. It'll just continue in the negative direction. Now, remember, my period is 2 pi over 3, so I want to make sure that's on here. 2 pi over 3 with enough, x values to the right and to the left, because we're going to do at least 2 full cycles. Here we go again. Vertical shift is up 3, so I'm going to start by putting a nice horizontal line at that new center of my graph, which is up 3, or at y is equal to 3. It's a cosine function, so it's a U shape, with a reflection, so it's an upside down U shape. So I'm expecting this kind of shape. So we're going to start at a min. Now, what was my amplitude? My amplitude was 4, and my phase shift is 2 pi over 3. So at 2 pi over 3, I'm going to go to the min. So that is 4 units from here. 1, 2, 3, 4, down to -1. I'm going to go to the next value, and it should be an intercept on the new horizontal. The next value should be at a maximum. Amplitude is 4, so 4 units above this line. 1, 2, 3, 4, up here at 7. The next x-coordinate at the intercept, or along that horizontal line, and the last one down to -1, 4 units at the min, down from that horizontal line. And let me do the best that I can to connect these beautifully. And here is my rough sketch. Let me actually do that again. Let me try to connect this beautifully. Boom, boom, boom. Let's connect it. That's a little better. And as you can see, I'm going to visually check it. I see vertical shift up 3. The distance from the center to the top is 1, 2, 3, 4 units, right? My amplitude was 4. The distance from the center down to the lowest point is 1, 2, 3, 4 units. It looks like a reflection because it's facing down instead of up. I start at 2 pi over 3. My phase shift was 2 pi over 3. It occurs in 2 pi over 3 radians. One cycle occurs in that period, 2 pi over 3. So everything here matches what I said initially. And this is just a visual check. And again, like I said, I graph this without going through the table. But you're going to want to write these points on the graph if you don't have the table shown. And I can verify my points too if my table's here. 2 pi over 3, -1. 2 pi over 3, -1. 5 pi over 6, 3. Let's check that. 5 pi over 6, 3. Pi, 7. Pi, 7, right? 7 pi over 6, 3. 7 pi over 6, 3. 4 pi over 3, -1. 4 pi over 3, -1. Everything matches. Once I have everything in there, it's very simple. Now I go to the left or to the right to continue the graph. I'm probably going to go to the left because I don't have a lot of space to the right. Could technically go to the right too just to show you. Let's do that real quick. This is the min, so the next one would occur at an intercept. The next one would occur at a maximum. Then the next one would occur at an intercept, and then back down to a min. So if I continue in this direction with another full cycle, another full period, there's another one. Up and down we go. Back to a intercept. At the next point to a maximum. Then to a intercept. Down to a min. Here's another full cycle. I could do as many as I want now that I have the main curve, because I just keep going up and down in a similar way as this one. Here's 3 full cycles, 3 full periods to represent this nice little cosine function with all transformations shown: reflection, amplitude change, period change, phase shift, and vertical shift. Okay, this is what the graph looks like. Nice, clean, organized. Again, like I told my students, distance between key points, this helps you make it nice and clean so that everything is equidistant from each key point to the next. That's why we count along the x-axis based on what this is. And it helps us determine our key points here. Any questions, let me know. Comment underneath. If you guys need another example, let me know. Comment, subscribe. Good luck.